This is my presentation on setting gas versus electric stoves with a Flux Tech heat monitor. So, I believe that the right word would be conduction for the experiment I did. Conduction is the process by which heat or electricity is directly transmitted through a substance when there is a difference of temperature of two touching regions without movement of the material. So as you can see, the hand holding the rod would feel the heat from the flame, and that would be the conduction here. So my experiment, you can kind of see in the back the setup. I used the Flux Tech. I put a cloth down to protect from the bare metal. That was just a precaution. I didn't know. I didn't want to melt the sensor. I put a wood on top just to hold down the sensor so it wasn't up at all. On the electric stove, I set the heat, the electric stove's on the bottom. I set the heat to about 3. And then on the gas, there wasn't any numbers, but I set the heat to around where 3 would be between low and medium. I took my measurements for about 25 minutes with a cast iron. It was 25 minutes was about when the curves were kind of ending. The gas stove one, the curve kind of the Flux Tech kind of failed and it said it was loading. I was really scared I was going to lose my data, but it ended up saving, and after 30 minutes of measuring, I wasn't going to remeasure. So here's the results from that. As you can see, well, the electric stove actually did flatten out really nicely towards the end, and so the data stopping wasn't too much of a problem. This is the temperature graph, and so the gas, you can see, heated up way more quickly and got to a higher temperature about the same time. So it was really interesting where like 3 on the gas stove would be so much higher of a temperature than 3 on the electric stove. But they both, after about 25 minutes, kind of hit that plateau, which was really interesting. So the calculations I did was I compared the heat transfer and emissivity from an electric stove to that of a gas stove at the same conditions. I tried to make sure the pan started off cold, around the same temperature, as you can see from the graph before. Oh, it won't let me go back. But the graph before, they kind of started off a little bit different temperatures. I think it was just colder in the first one. But yeah, same conditions. I assumed the temperature of the surrounding was about 23 degrees Celsius or 296 Kelvin, which is about an average room temperature. I found the average values from about 30 seconds after the peak, so I just chose those last 30 seconds from my graph, that kind of where that flatter spot, to provide a good comparison. As you can see, the gas stove was much higher in temperature over, like, these were both just averaged over that last 30 seconds, and then the heat flux for the gas stove was much, much higher, and I think the graph kind of showed that. So some more calculations were done. They were based on the measured temperatures and heat flux for the cast iron. The corresponding emissivity was found. Here we neglected convection and assumed that the surfaces are very close, so meaning the Flux Tech was pressed completely on the cloth, and I believe that was happening because of the wood that I added on. I did end up getting an emissivity of 1.13 for the electric stove, which makes sense and is very similar to the lab that we did. But for the gas stove, the emissivity was really high. But when looking at the heat flux and everything like that, it seems to kind of make sense. The only thing that really confuses me is here you can see this huge jump in the gas stove heat flux, and I'm not really sure why that happened, or if it was just two different points. Yeah, I'm a bit confused on that one, but that would be one of the kind of questions I have. And moving on, so now moving on to my actual questions, errors, and possible answers to my questions and errors. I think there was a lot of errors in this. This is just an at-home experiment. Basically, I could have started the pan off at different temperatures. The fact that a 3 on an electric or a gas stove was so much hotter could have something to do with it. I'm not sure if emissivity actually makes sense to be calculated for this. I thought it was, and as I was looking at it, I was like unsure if that would make sense to do that for conduction. So that would be the biggest question that I have is if that's allowed, but I was not going to redo all of the calculations once I finished. I'm not sure why it changes so drastically between the gas and electric stove. I think temperature, of course, had huge fact to do with it. The emissivity is like based off of temperature, and so is heat flux over time. And since the gas stove was going like so much higher in temperature over the same amount of time, but much more quickly, that definitely I think is a factor. Why is the heat flux? That kind of goes into why is the heat flux so high for a gas stove? It's heated up faster and to a higher temperature. So I think the heat flux makes sense. But yeah, there's my project. Thank you.